Morning, students. Today our topic is correlation of discrete time signal. First of all, you should know what is correlation and why do we study in signal system. Basically, correlation is the measure of the degree to which two signals are similar. And correlation can be of two types, that is cross correlation and autocorrelation. What is the difference between cross correlation and autocorrelation? Basically, correlating is comparing two signals. Correlation is basically comparing two signals, whether they are similar or not. If they are similar, then what we will call it, and if they are not similar, if they are different, then what will we call it? So cross correlation is a situation when the two signals are different from each other. That is, they are not similar. When two signals are not similar, then we will define it as cross correlation. And when the signals are similar and they are having the same property and same nature, then these types of signals are known as autocorrelation. So basically, correlation is very important in a signal and system subject, and beyond the subject, you can see the use of correlation in radar, in sonar, in digital communication, in geology, and many more. Sometimes students get confused what is radar. Radar are nothing but electromagnetic waves. Each and every country use this system to know who the the person who are entering in their country and who are exiting it. For example, we are from, if I talk about Indian Pakistan border, we have very high radar, very high quality of radar system, so that we can know each and every movement of aircrafts, aircrafts and other air force movement, and it also used on the ground level as well. So it is very important to know that correlation of signals is in very much used in the radar system. Second is your digital communication. Like digital communication also include, like I'm communicating to you, and when you are on a phone call, you are communicating over a phone call, or you are communicating over a net, using net. So, and in geology, in geography, they use the signals to sometimes identify the how far away is the matter from the people, how the like in in like, for example, earthquakes, and then the movements of the plate, the movement of primary and secondary waves in our earth, in the core system. This correlation of signal is used in that also. Now I want to explain a bit more in this. Like if a person is sitting in Gujarat and he wants to communicate to his friend who is sitting in Delhi, and he or she make the phone call to his friend, then who is making a call is sitting in Gujarat, and whom he wants to communicate is sitting in Delhi. So the Gujarat person is the transmitting end, and the Delhi person is the receiving end. So we can, for our understanding, we can denote XN at transmitting end and YN at the receiving end. Fine. So we can see generally that there is a lag in the communication when we transmit a signal at the receiver end. There is a delay. Sometimes over a Google Meet or Zoom classes, you also face some lag in the voice of the teacher, and it is retrieving to the student. So there will be a lag. There will be a delay. We call it delay samples in our signal system. So there will be delay when the transmitter sending a message to the receiver end. Till it received by the receiver, it will delay by some samples. Here you can see the some equations like R, X, bracket in it's L. L is known as here shifting parameter. So I should write it here. For your convenience, this L is your shifting parameter. And your L value can be, 0 plus minus 1. L is equals to 0. This must be a small L, not the capital L. Equals to 0, comma, it's your minus plus minus 1, okay, plus minus 2, plus minus 3, and so on. It can be like that. ये plus 1 भी हो सकता है, minus 1 भी हो सकता है. Like plus 1, plus minus 1, plus minus 2, and so on. Well, in the next video, we will see is numerical based on autocorrelation. It is very important to know how the shifting of the signals is, going on. So this is the expression for autocorrelation. This is the expression for the autocorrelation. And the two signals are similar. Autocorrelation. And this is the cross correlation. Here you can see that we have taken XX, that is a similar signal, and here we have taken XY, that are the different signals. So the equation will be summation n is equals to minus infinity to infinity. Here is the limit x and minus L. And in case of cross correlation, this will be gonna R x y L is equals to summation n is equals to minus infinity to infinity x and y and minus L. Okay, so please remember it that when two signal sequences, that is xn and yn, are compared in radar, for example, in radar application, then xn can represent your sample version of transmitted signal, and yn can represent the sample version of your received signal at the output of AD converter. And if a target is present in the space being searched by the radar or sonar, the received signal yn consists of a delayed version. Okay, consists of a delayed version of the transmitted signal refracted from the target, and complete. Actually, it is also intercepted by the additive noise. I must add in some point like that. If a receiver is receiving signal with some delay, along with the delay, there will be noise also. There will be also presence of noise. And what is noise? Sometimes people get confused. And if in an interview, there was a question that noise is signal or not, and the candidate said that noise is not a signal. I must correct you that noise is also a signal, but it is unwanted signal. Okay? The signal that you doesn't require. So noise is a signal, but it is a unwanted signal. For example, if a person loves to hear smooth music like slow music, then a disco song will be a noise for him. But if a person like a disco and pop songs, then it will not be a noise for him. It will his requirement. So it will not an unwanted signal. So I think noise concept is also clear here. That unwanted signal is called noise. So students, thank you. I hope that you require you get some information from this lecture. And in the upcoming lecture, we will see a numerical based on autocorrelation. So thank you.